This is section 8.2, part 2. At the end of the last video, we were talking about how we broke up 24 as 4 times 6 and split it into 2 radicals and simplified. This is simplified. You're always going to have to simplify your radicals. This is not the easiest way to do it. What we want to look at is prime factorization. Just as a reminder, what your prime numbers are, here are all the prime numbers less than 100. These are the numbers that are only divisible by themselves and 1. 2 is our only even prime number because every other even number is also divisible by 2. So most of them, all but one of them are odd numbers. What we want to do is any number we can think of, can be written as a multiplication problem involving only prime numbers. Now, the first way you may have learned prime factorization is what we call the factor tree. And what you would do is you would take the number you're trying to split up, 24, and you would try to think of 2 numbers that multiply to 24. I don't want to use 4 and 6 again, so let's go with 3 and 8. 3 is a prime number, so it is a dead end. I circle my dead ends so that they're easier to find. If your tree gets really large, you can lose dead ends, and you need all of them. Okay? Now we repeat. 8 is not a prime. I want to think of 2 things that multiply to 8, and I don't want to use 1 and 8. So that gives us 2 and 4. 2 is a prime number. It's a dead end. 4 is not prime. It can be split up into 2s as well. Eventually, you will end up with all prime numbers. Everything will come to a dead end. That means 24 can be written as 2 times 2 times 2 times 3. Okay, now if you had chosen a different breakdown here, if you had chosen 2 and 12, you still would have ended up with these numbers in a different order, but you would have still ended up with 3 2s and a 3. Okay, so this is one way to do a prime factorization. And then what you do is you look at the index of the radical. My index was an understood 2. That means I'm looking for pairs. Here I have a pair of 2s. I don't have any other pairs here. If you have a pair, it comes on the outside. So I have a pair of 2s. And then what do I have stuck on the inside? I have a 2 times 3, which is 6. And if you compare that to here, we get the same answer. We're going to be doing a lot more of this. Don't worry about it just yet. Okay? So there's the factor tree method. What I'm going to show you now is another method of getting it done. And I prefer it because it takes up less room and it tends to be very easily reusable. I'm going to have a separate sheet of paper and I'm going to do my prime factorizations here. And this is called repeated division model. Okay, so what I want to do is I'm going to take 24 and I want to think of a prime number that divides evenly into 24. I don't want to use 8 because 8's not prime. I don't want to use 4 because it's not prime. I just want to find a prime number that goes into it. To me, 2s and 5s are the easiest things to see. If it's even, it's divisible by 2 until it's not even anymore. If it ends in a 5 or a 0, it's divisible by 5 until it doesn't end in a 5 or a 0 anymore. So let's try dividing this by 2. It's just like regular division, it's just our sign is upside down. 2 divided into 24 is 12. And then I keep going. What's a prime number that goes into 12? Well, 2 can go into that again. And that gives me a 6. And then a 2 divides into 6 as well, leaving me with the 3. So eventually, I end up with the same prime numbers I did here. They're just on the outside. Okay? So if I'm looking for a square root, I'm looking for pairs. Here's a pair of 2s. So a 2 comes on the outside. And I have a 2 times 3, which is 6, still on the inside. So I found that the square root of 24 is 2 times the square root of 6. So I've now done this 3 different ways.